Hey everybody, and welcome to our podcast for May 22nd. We're doing something totally different today. I know that we've been getting a lot of information out to the service centers and to our salespeople and to everybody else that's technical out there. This time we're going to do something a little different. We're going to be heading right towards MBAA Tech Committee and CJP. So on our side, we follow the CJP website and the blog quite religiously. We analyze pretty much everything that's said on there, and last week we had a whole bunch of posts on WAAS and some of the CJ aircraft. So what we've done this week is we've gotten together a bunch of people that are really pretty much experts in their area, and we're going to have them try and do a kind of a group review, a panel discussion on WAAS. It's going to be informal. They're going to be asking questions of each other. They've also taken some of the information that you've put out on the blog, and they're going to try and answer questions that you've posted too. So again, please hope you enjoy it. If there's any questions, any concerns, or anything else that you'd like to see, let us know and we'll get that information out to you. Again, thank you for your participation.
Well, hello everyone. As JD has already mentioned, we have convened a panel of 4 of us here from around Cessna who are going to discuss WAAS as it pertains specifically to CJ series aircraft. And before we get started, we're going to go ahead and introduce ourselves. My name is Joel Mugglin. I'm a program manager in customer service. I'm also an avid flight instructor at the Cessna Employees Flying Club. I also have a background as an A&P mechanic, as well as in various customer serving positions in technical marketing through the years at Cessna. And so that's my background.
Well, hello, my name's Greg Potter, and I'm a CJ pilot. I'm a former demo pilot here for Cessna. Currently, I work for engineering business development, where I've been engaged in NextGen technology, both how we can outfit our existing fleet as well as our legacy fleet, and I've also been working human factors projects associated with it.
Hello, my name is Dave Luckert. I'm a manager of an engineering group that supports aftermarket avionics at citation service centers. I've been with Cessna about 20 years, have been keenly involved with developing solutions for our aftermarket, and have been involved with the WAAS retrofit programs.
Hi, my name is Rob Below. I'm in customer support. I handle pretty much any topic that has anything to do with the flight manuals for any of the citation aircraft. Been in customer service for 15 years, and I handle a lot of questions pertaining to WAAS and related topics. I also have a type rating in the Mustang, an A&P certificate, and about 750 hours.
Okay, well, let's get started then, gentlemen. You know, we're aware that some people watching this video may not have a very strong picture of what WAAS is and can do for them. Obviously, here in the United States, we use WAAS a lot. In our GPS receivers, we conduct LPV approaches rather routinely in some cases, depending perhaps on where we fly in the country. But outside the United States, people aren't accustomed to these approaches yet, and in order to level set everyone, we will just give a few quick definitions so that people understand the terminology that we're going to be using in this discussion. First of all, as most people are aware, WAAS, the acronym stands for the Wide Area Augmentation System. It provides a correction to the basic GPS signal, which corrects for atmospheric effects that can change or alter how that GPS signal is received in larger regions of a particular country. In this case, the United States is well covered. We even have WAAS receiver stations up in Canada, reference stations as they're called, up in Canada, and there's some down in Mexico as well. You can see the red dots there that represent the reference stations that provide the correction to the GPS signal. That correction is then uplinked to 2 geostationary satellites via, they're called the ground uplink stations. Those are the pink triangles there. And the signal actually it goes through the blue stars, which are the wide area reference stations. So in any event, they all go up to the satellites and then get retransmitted down to all the GPS receivers that are WAAS enabled. This provides a correction to the signal both in the horizontal and the vertical direction. So now the vertical component of WAAS, of GPS signals, become usable for approach capability. That's really what we're looking at. There are some particular terms that we need to also clarify with regard to approaches themselves, because this is where a significant portion of the benefit, not all of it, but a significant portion of the benefit of WAAS capability comes in. The first term I want to introduce is LNAV. That's simply like a typical GPS approach. Most pilots are used to this, where you have no vertical guidance at all. You don't need WAAS to do this. You simply need GPS receivers to do this. And you typically think of this as a step-down approach to a minimum descent altitude. But of course, there are some FMSs that can generate a pseudo glide path even for those types of approaches. So that is possible. It's not necessarily always step-down, but the basic approach design is a step-down approach, non-precision. Next up the scale is what we call an LNAV VNAV approach. This is, again, pretty widespread here in the United States. You can see an example of minimums there for happens to be Bend Municipal Airport in Oregon. You can see an LNAV VNAV line of minima there. Goes down to a decision altitude in this case, because this is more like a precision approach. You have vertical guidance to a decision altitude, and that is based upon barometric altitude. There's no WAAS component required for this type of approach either, though it is more like a precision approach. Then if you move just a little bit further up there on the chart, on the minimum section of the chart, you'll see the LPV line of minimums. In this case, you do need WAAS to shoot the approach down to that altitude. You can see it's all the way down to 250 feet AGL. Some cases, LPV minimums can be as low as 200 feet AGL, similar to an ILS. So you can see how it gets better as you go from LNAV to LNAV VNAV to LPV. You do get vertical guidance for this as well. And I would like to point out that there are about 3,100 of these approaches now in the United States, compared with about 1,300 ILS approaches. So it has more than doubled the number of ILS approaches in the United States already. And the number continues to grow. There's one other term you may hear us use in this discussion. It's growing here in the United States. They're called LP approaches. At an airport where it's not possible for the FAA to design an LPV approach with the vertical component of the guidance, they will in some cases introduce an LP line of minimums. You can see one there for Batavia, Ohio. You'll never see LPV and LP on the same chart at the same time. This is only if they can't do the vertical component. WAAS is required for this type of approach, but it's very similar to an LNAV only approach. The only difference is that in this case, instead of using barometric altimetry, you're not using WAAS vertical, you're just using WAAS lateral correction, okay? You are still using barometric altimetry. So that's just something to point out. There are 414 of these approaches in the US with LP minimums, so that number continues to grow as well. So we're seeing a lot of these already starting to appear.
Can I jump in for a second?
Yes, you may. Please do.
I think a layman's approach to WAAS is that a WAAS approach with LPV guidance loads and acts like an ILS, or an LP approach loads like a localizer-only approach. But in both cases, WAAS and LP, you're using GPS instead of ground-based nav aids.
One question that comes up is, why should I consider equipping my aircraft with WAAS capability? Even though these approaches are becoming very widespread, there are still quite a number of ILS approaches and other types of approaches that people can use. And so we do want to address this question. It's a very pertinent one. And to do that, I'm going to turn to Greg and have him explain.
Well, the answer begins with, or I should say it ends with, you really don't have a choice. The world is going through a transformation in the way we manage aircraft. There's all sorts of names all around the globe to identify these projects. Here in the US, we call it NextGen. If you're not familiar with NextGen, I'd encourage you to go to the FAA site and just start reading about it. What you'll find out is we're in the middle of implementing a paradigm shifting way of managing aircraft that begins with the GPS. And the GPS is going to be required as an SBAS GPS. And it stands for the Satellite-Based Augmented System. And one of the features that SBAS is going to allow is this WAAS capability. Now, when you look at the chart that I have up here, up the upper right, you're going to see a timeline of mandates. Now these mandates, some of them have already taken place, like the ones in some of the Link 2000 in Europe, and some of them haven't, such as the 2020 mandate here in the United States. But when you look very closely, you'll see that there's only one mandate that's associated with the United States. The rest of these are around the world. There's this global transformation that's taken place, and this WAAS SBAS system is part of it. The final thing that you have to know is that the old system, the VORs, the ILSs, the ground-based radar systems, they're going away. The FAA currently has a plan. They haven't released the details yet, but their plans is that they're going to start winding down or decommissioning some of these sites and have only a skeletal system in place by 2020. So the short answer to your question, why do I want to equip with an SBAS GPS with WAAS capability? Well, you really don't have a choice. Now, there's some other things to look at. The slide that's up on the screen now, I have both hard and soft mandates. Now, hard mandates are the ones that are mandated by law. For example, the ADS-B transponder is mandated by law in both the U.S. and Europe, beginning in 2020 for the U.S. and 2017 for Europe. And there's other places around the world where ADS-B is also mandated, such as Australia. Now, here's the thing you need to hear. The ADS-B out transponder requires a signal from the SBAS GPS. So in order to comply with the mandate in 2017 or 2020, you're going to have to get an SBAS GPS. Furthermore, there's what we call soft mandates. These aren't mandates that are mandated by law, but they're more by policy. Some of you may have heard the term best equipped, best served. The FAA thinks that the sale case for NextGen and the associated technology is difficult. They're talking to folks such as yourself and finding out that there's really no business case to equip, at least not early. And so they artificially are adopting an operational policy called best equipped, best served, meaning that if you're properly equipped with things such as an SBAS WAAS capability, you might move to the front of the line. If you're equipped with an ADS-B out transponder, particularly in the Northeast, like in the New York area, you're going to move to the front of the line. And so this best equipped, best served is not a mandate, but it's a soft mandate because it's an operational policy. And of course, don't forget that these ILSs, as they age, if you're in a non-critical airfield, your ILS may be decommissioned. And in which case, I'm going to have to ask you, is if you don't have an ILS, what approach are you going to fly in poor weather? Now, so there's some other advantages to the SBAS.
Mind if I just add a comment there? There's a lot of small airports out there that can't afford an ILS, but they can get an LPV approach. And so today, there's a real advantage in being able to fly LPV approaches. And that advantage is just going to get bigger as time goes by. No ILS, but you've got an LPV. Fly that.
And these ILSs can go away by attrition, correct?
That's correct. You know, the perverse effect of the government budget process right now is, well, they're looking for places to cut money. Why repair an ILS that's scheduled to be brought down? So maybe they'll take it down earlier than expected.
Yeah.
Other things to consider, operational advantages of the SBAS. First of all, the subject of this conversation is the WAAS LPV approaches. The WAAS LPV, like was previously mentioned, they're like the ILS. I mean, when you're sitting in the cockpit, you fly it very similar. But it lacks, I should say it corrects, or it doesn't have the natural instabilities that are in the ILS, and it doesn't have the weakness of relying on the barrel nav that is required for the LNAV, VNAV. And so the WAAS LPV is really a better product. And when you buy the SBAS GPS, it's one of the features that comes with it. Other features include these optimized profile descents. I don't know where you've been flying out of, but if you are in the Metroplex regions, there's a lot of these R&P type procedures to streamline both arrivals and departures. The SBAS has the requisite capabilities to perform those. And then finally, ADS-B. There is some advantage to equipping ADS-B early depending on where you operate, particularly if you operate on the East Coast. One thing I also like to point out is, you know, there's economic advantages. You know, why spend the money now? Well, think about asset protection. As the FAA implements policies like best equipped, best served, they're going to, by design, on purpose, tell aircraft that are not properly equipped, they got to go hold or divert, or you're not going to have access to airspace. Well, once you start to lose access to airspace, your aircraft as a business tool starts to lose utility. And so as it loses utility, your natural depreciation rate is going to accelerate. In order to protect that asset value, you really need to equip. Now you might say, well, gosh, I'm just going to sell my aircraft. Well, my question is, who are you going to sell it to? And don't forget, even if you say, well, I don't want to equip early, first guy to spend money is going to lose money. Well, there's some truth to that, and there's a reason to have that opinion. But if everybody waits to the last minute, there's going to be a very large queue at the modification shops, and you might not be equipped in time.
I have a quick question.
Yeah.
The ODP descent path.
Yes.
That's going to take the place of a step down.
Yes.
That's provided by ATC, and instead you're just going to fly from an en route altitude, steady descent along vertical path to.
Well, that's correct. Right now we know that our normal arrivals is we get step down fixes, an intermediate fix, usually 11, 15,000 feet, somewhere in there. Mm-hmm. And so we come out of our efficient operating cruise altitude prior to our natural top of descent, and then we cruise at lower altitudes that are inefficient fuel-wise, and then we cruise again down, or descend again down to probably a final vectoring altitude, 3,000, 4,000 feet, whatever it happens to be.
Intercept.
And you get vectors, and those vectors can vary depending on the time of day, weather, traffic. I mean, there's a number of variables, how fast the guys are going in front of you or relative to you. And so that box becomes very variable, and you can burn a lot of gas. And these OPDs are designed to allow the aircraft to descend at its natural top of descent at a constant power setting, so you can just keep the throttles back. If you have the RNP, RF leg capability on your aircraft, you'll fly a very precise path, maybe a turn to final. And we've done some analyzation on some of these approaches, particularly the one that's down in Houston. And we modeled Citation 10 on one of their ODPs and compared it to their conventional arrival. And it saved the 10 about 13 minutes of flying time and about 450 or so pounds of gas.
And those are published?
Yeah. No. Those
assigned or?
What do you mean published?
ODPs.
Oh yes, yeah. You have to be equipped for it.
Gotcha.
And
gotcha.
And different metroplex regions, different airports have different levels of approaches available to you.
Okay, thanks. Thanks.
Okay, well, let's move on to our next question, which we'd like to address, and that is, if my airplane is equipped with a WAAS-enabled GPS receiver and FMS, does that automatically mean I can conduct LPV approaches? Rob, I think I'd like to ask you to go ahead and handle this one.
No, it doesn't. Not necessarily. We have flight manual supplements that in one way or another will specifically tell you that that installation and that airframe with that flight control system supports WAAS approaches. In the CJs, in the 510, the title page on the supplement says WAAS. There are other supplements where the WAAS or LPV references buried a little bit down in the supplement. But in general, you need a flight manual supplement that says WAAS either on the title page or a reference to that capability in the section of the supplement called Navigation Operational Capabilities. That's typically where you find things like RNP4, RNP10, BRNAV, RNAV1, RNAV2, SID stars, and WAAS. If it's not there, then there should be at least a reference as to how to fly an LPV approach in the limitations section of that supplement. So either title page, Navigation Operational Capabilities, or limitations, you should see support for WAAS operations.
From a technical point of view, too, I mean, that addresses the supplement side of it, but what has to be present in the aircraft in addition to the WAAS-capable FMS in order to conduct the approach?
Well, you'd have to have LPV enunciated on the PFD. Typically with an older airplane, it's an update to the receiver, the FMS software, things like that.
Mm-hmm. Right. and the glide slope or the glide path indication.
Yeah, you'll instead of a green diamond, you'll see a purple diamond, and the PFD should enunciate LPV.
Okay, good. Okay, next question. What WAAS capabilities are available on current CJ1+, 2+, 3, and 4 aircraft? And by this we mean aircraft that have delivered relatively recently from the factory within the last few years. The 1+, of course, is out of production now, but we still have the 2+, the 3, and the 4. And the answer to that one is that there are, basically since 2009, the 1+, 2+, and 3 have had the capability to conduct WAAS LPV approaches as standard equipment. We made that change at that time, recognizing what was happening in the world, and particularly in the United States, and just equipped them that way from that point on as standard. The CJ4 entered service in 2010, also fully WAAS LPV capable. But the one thing to understand is that these aircraft all have the Collins FMS 3000 in there. You can have that as a single installation. There's an optional dual installation, but that's the basis on those aircraft platforms for conducting WAAS LPV operations. There is, on the 2+ and the 3 still today, an option for Garmin GPS 500W. We even have the W or WAAS version of it, which is interfaced to the flight director and the autopilot for LNAV only. It's still not possible for us to interface that for VNAV, though, due to interface issues between the Garmin and the Collins Proline 21 system. So it's still only for LNAV. You can't use the Garmin GPS 500W to conduct a WAAS LPV approach, even though the GPS receiver itself is WAAS capable. That's an important point to understand. So that's what we have with the relatively recent aircraft. But what about the 1 and 2+? This is where we get into the meat of our discussion today. What about, have we left them out in the cold? What about the 1 and 2 operators out there that don't have a Collins FMS 3000? And for this, we're going to turn to Dave Luckert.
Thanks, Joel. First thing I'd like to explain is that the Proline 21 suite that's in a number of these models, we often see that as being the same suite, but in reality there is some significant differences between the Proline 21 suite that's in the CJ1 and 2 and the Plus models and above. And some of those differences involve the fact that these things were designed prior to the designers knowing the requirements for WAAS. So they're not really able to support vertical coupled flight from the FMS. It's just not in the design. So a couple years ago, we were listening to our customers at our customer conference, and we heard clearly that there was a need for this. So we contracted with Collins to modify the Proline 21 for the CJ1 and 2. And we did it in such a way that we could couple a Garmin or a Universal WAAS product to the Proline 21 to support coupled LPV. And that was completed in December of 2012 and is now available through our citation service centers. When we entered this program, we took a look at the wide range of long-range navs that we had delivered the aircraft with. I think that's on the slide now. The ones that we pursued were the long-range navs that were most common. So we developed solutions for the Garmin 530s, 430s, any combination of those, or the UNS 1L. So those are available today and can be purchased, and you can fly WAAS LPV fully coupled with those solutions. Citation service centers, you can contact them for further information. We put some information sheets together to tell you what the capabilities are and the pricing on that.
Okay, another question that we'd like to address at this point is what options are available for WAAS LPV capability on the original Citation jet? We've talked about the more recent aircraft, the 1 and the 2, the CJ1 and 2, and now we want to go back to the Citation jet.
Kind of like the Citation 1 and 2, as we go further back, the avionics, again, clearly is not designed for coupled FMS vertical operations. So that was the same with the Honeywell IC500. When we were getting inquiries to support or implement WAAS into this airframe, we did contact the supplier, Honeywell, and determined it was really not economically feasible to upgrade the IC500. So our options were, we either add a WAAS with some type of independent display, or we tried to make some kind of adapter, or we totally replaced the flight guidance system, the EFIS system, and the autopilot system with something that would be desirable, like the G1000. But before we talk about the G1000, I'd like to take just a minute to talk about the IC500 and some of the obstacles of why it's not easy to connect to that. We get a number of inquiries on that, so we thought we'd take just a little bit of time to explain the issues. In the illustration you see here, we have the blue box representing the IC500, which is the main computer that's standard on the Citation jet. It is a box that contains the autopilot, the flight director, and the EFIS symbol generator system. There's two basic forms of navigation inputs into this. The green represents the short-range nav, nav 1 and 2, and the magenta represents the FMS. The IC500 is currently designed only to allow vertical coupled flight through those green inputs, through the short-range nav. There's just no way to couple vertical into the magenta input there, the long-range nav input. There's no software, no hardware there to support that.
And when you say short-range nav, you're pretty much talking about ground-based nav aids, right?
Correct. That'd be in this particular case, to get vertical, we're going to be talking about going in the ILS channel.
Hence the, wondered how you pick green versus magenta there.
Exactly. Next slide, please. Now, some people would think, well, maybe we make an adapter, and when you think about, let me back up just a minute. When you think about the green, the short-range nav channel, think of it as the short-range nav having its own language, and think about the long-range port having its own language. So to try to take the long-range nav signal and put it into the short-range nav port so we can fly using the ILS, we would have to have some kind of converter to convert the long-range nav language into the short-range nav language. That would be possible, but it's problematic because what will happen is the EFIS system would display all the colors and labels of a short-range nav. You would have to have some small external enunciator to say, disregard the symbology and the labels inside the EFIS and use what's labeled on the enunciator.
Follow the needle, but ignore the enunciations.
It'll be green, and you have to know that you're coupled to the FMS.
It's not ideal. It's questionable whether it could be certified, but it is not ideal. But the problems go deeper than that. The next slide is a bit hard to explain, but let me give it an attempt here. What's shown here is like similar to a typical localizer. And you'll see that the angle A represents maybe the localizer approach. And you'll see as you get tighter toward the runway, the full-scale deflection, which is the FSD, angle A represents your full-scale deflection. A localizer and a glide slope is an angular deviation, okay? Its full-scale deflection will change as a function of that angle as you get closer. Now the magenta lines there are the long-range nav system. Now the long-range nav uses linear deviation, so it will be parallel to the center line, and then it transitions to angular, and then it goes back to linear. There are problems and challenges when trying to send a linear deviation signal into an angular port. The short-range nav port on the IC500 will be expecting an angular signal. So what can happen? What can happen here, it will illustrate, when you're far from the touchdown point, up in the upper right-hand corner, you can see that if the FMS is putting out its full-scale deflection, it'll think full-scale deflection is where the magenta line there is there.
The dotted line.
Correct. But the autopilot will assume full-scale deflection lies on angle A. So the problem is that the autopilot's gains will think you're further from the center line and may give you a too aggressive maneuver to get back on center line. Correct. And when you look close to the touchdown point, the reverse is true. Full-scale deflection would be the magenta dotted lines parallel with the runway there. And the angle A, the autopilot will think full-scale deflection is on angle A. So as a result, when you're close to the runway, the autopilot will think you're closer than you really are at full-scale deflection and may not give you sufficient authority to remain on track. The G1000 is our primary solution for upgrading the Citation jet aircraft. When we consider all these possible ways to provide WAAS, we really felt that we'd spend a lot of money creating a Band-Aid, quite frankly. And we thought we'd rather invest that into a foundation that would be a good solution for not only WAAS, but would build on the future, what you need for all the future mandates.
A solid solution.
Correct.
Okay, thank you, Dave. Another question, Dave, for you that I think people are wondering, and I think you've kind of touched on this, but you might just reiterate. Are there any simpler, less expensive solutions than the ones already outlined? Because obviously a complete cockpit retrofit is a pricier solution, there's no question. So are there any cheaper ones than that for the CJ in particular, and why is it so expensive to upgrade to WAAS?
Sure. Well, there are all kinds of possible ways to upgrade aircraft, and we have looked at all of those. I can tell you that one of our key factors in our decision-making process was to look toward the future. We wanted to make sure that when the ILSs are decommissioned, that you're not left without having any form of a coupled precision approach. So our path was to ensure that you had a means to couple WAAS. So that's the primary direction we went: autopilot, vertical coupled approach capabilities.
Can I jump in here a minute? I think this is a very important point that we need to emphasize. You can get a Band-Aid fix, perhaps, but what you're going to end up doing is boxing yourself into a corner. We have a slide that we can put up here that's going to show that this transition to NextGen around the world is going to be in multiple phases. And if you block yourself off early in the early phases, what you're going to do is you're going to make your aircraft unable. There's not going to be a path to continue the upgrade process to make it NextGen capable. So you're going to have to do one of two things: junk your aircraft,
Start over,
or uninstall the Band-Aid you put on and come back and do it the right way. And so when we go to do these upgrades, whether it's the SBAS with the WAAS or the ADSB or TCAS or any of these things that we're starting a conversation about, you need to keep the end goal in mind that you have to, these are intermediate steps as we progress to the ultimate configuration we're shooting for in about 10 or 15 years.
So flying an approach is great with a Band-Aid, but you're not going to be able to build on it. It's not
that's
a foundation.
right, and it is going to be an obsolete system as we move through these successive technology blocks that are laid out, and they're harmonized around the world by ICAO.
Joe, you'd asked why WAAS is so expensive. Well, it's difficult to quantify expensive, but I can tell you that for the legacy aircraft, a lot of it is the fact that the systems just weren't. The designers were not aware of WAAS when they designed the systems that are in your aircraft. So what that means generally is quite often we're having to replace hardware. We don't have an upgrade path on hardware, so that's one area of the expense. Also, the flight guidance systems, as we just talked about a few minutes ago, the flight guidance systems quite often also have to be altered and upgraded. And the EFIS. WAAS GPS has levels of service enunciators that must be in place. So either EFIS changes would occur or external enunciators would be required. In addition to that, we have to look at TAWS-A for the glide path protection. Sometimes we have to modify the TAWS system to support WAAS. And on top of that, our suppliers, Rockwell Collins and others, invest a lot of money to bring these products to you. So there's certainly development cost on their part. There's development cost on Cessna's part, and then there's FAA certification. Today, the FAA still pretty much pushes that WAAS will be certified by either a supplemental type certificate or a type certificate. Unfortunately, that is an expensive process and it's a time-consuming process, but that is what we have today, and we work with it.
Okay, thank you. Okay, another question, and this will be basically our last question.
Just a second before you go on to that one. On
Yeah.
the last topic, when you think about expense, if you have a $2 million CJ and you say, well, gosh, this is relative to the hull value. I mean, this is just an incredible price. The problem you're going to run into if you don't do it is your $2 million CJ is going to be a $0 CJ. And so it's part of that protection of the asset value. So it's hard when somebody says, why is this so expensive? Well, there's a lot of factors to consider other than just the purchase and the installation price of, in this case, the WAAS LPV system.
I was just going to chime in also that I've been involved in steep approach over the years, and this is a similar thing where you're going to certify a new flight manual supplement that provides a new approach capability. And even if you don't have to upgrade the hardware or ask for new capabilities from the vendor, you still have to go out and fly the airplane, complete all the engineering reports, and typically you're looking at 6 figures just to do that within Cessna. And ballpark, rough order of magnitude, a man-month of engineering labor to get all that done. Mm-hmm. It's just not cheap.
Mm-hmm. Yeah, and it's true. I mean, when you're talking about something as precise as you have to be for a safe WAAS LPV approach down to 200 feet from the deck, you're talking about a level of assurance and certification that requires some significant flight testing.
And to get an FAA signature on it.
To get a signature, yeah. That's right. So. Okay, final question. What is the situation regarding conducting EGNOS-based APV approaches in Europe? EGNOS, for those who don't know, is the European equivalent of the US WAAS system. As Greg explained earlier, these all fall under the generic term SBAS, or Space-Based Augmentation Systems. EGNOS stands for European Geostationary Navigation Overlay System. And but in any event, it's a system just like WAAS. It still uses the US GPS constellation for the basic signal, then does the corrections through ground reference stations, just like here in the United States, uplinks the correction to satellites, and then sends it back down to the WAAS-capable GPS receivers. Eventually, Europe plans to launch their Galileo GPS system, that's their version of our basic GPS system. But in the meantime, they've gone ahead and, recognizing the benefits of WAAS LPV, they've gone ahead and launched their EGNOS system. And they call it an APV approach. We call it LPV. I guess we always have to have something a little different than the Europeans, but that's what they call it. And I believe that's also the ICAO term. And I've heard them called both in European circles, but mainly APV seems to be approach with vertical guidance is what that means, whereas we talk about a localizer precision with vertical guidance.
Well, they use APV to describe VNAV, barometric VNAV, as well as LPV.
Is that right?
APV is kind of an umbrella concept, isn't it, Craig?
Yeah, this is alphabet soup, and what I'm going to tell you today may be different tomorrow when somebody thinks up a new and more brilliant nomenclature. But the APV is equivalent to our LPV, or I should say the APV SBAS is equivalent to our LPV in the United States. Their APV Baro is equivalent to our LNAV VNAV. LNAV VNAV. And if you click the next slide over, and you see here's some of the terms to kind of help put it together. You can see kind of the LNAV is your non-precision approach. It goes to an MDA. It's a non-WAAS function. The LNAV VNAV is a non-WAAS function. Its equivalent is APV Baro in Europe. Used to be APV1. In fact, you might find publications that'll say APV1, but right now the approved term is APV Baro. It goes to decision height, and that's a Baro decision height. And then the LPV is the approach we've been talking about. Its equivalent is APV SBAS in Europe. It used to be APV2. It's WAAS. You have to have the WAAS system, WAAS SBAS GPS to fly it, and it flies you to a geometric decision height.
This is a list here on the screen of all of the approaches that are either completed, for which the European authorities have already completed developing an APV approach at these airports, or they're planning to. This several pages here The first page shows mostly airports in France. They were the first country to really jump onto this EGNOS APV capability. Then the next slide shows that Germany is really getting into the action too. We do have some in Switzerland and some in Italy as well, but really Germany seems to be the next major group of approaches that we can expect to see in terms of APV in Europe. And there's a couple of pages of those. Some of them are already complete, some of them are still in the works, but quite a list of them there. And this will only continue to accelerate. We are certainly very aware of that here at Cessna. I will say that our AFM supplements, similar to what Rob was saying earlier, have to say that a particular aircraft platform is certified and capable for such and such a type of approach.
Wait a minute, you mean if I have WAAS capable for the U.S. operations, I may not be able to operate in Europe?
That's correct. We have to, there's definitely, EASA is going to require us to do some verification to make sure that the systems are supposed to be totally interoperable, and they really are. That's been a goal since the beginning. However, we can't just assume anything when you're talking about something as critical as an approach like this. So there is going to definitely have to be some due diligence done, which will then result in our updating those supplements to indicate that fact. We don't have a firm timeline for that right now. It is definitely something we're aware of and working on. And at this point, I just have to estimate that it will be sometime around 2014. Hopefully, we can get that done as quickly as possible.
Question. So in the future, will we be looking for the catchphrase EGNOS APV2, where we see LPV in our current supplements?
Greg, do you know the answer to that? What will it call? What will we call
what
it?
will the catchphrase be there? Do we even know yet?
I don't think.
I think to some extent that will depend on what the guidance from Europe requires us to call it. I think you'll probably see something along the lines of SBAS, APV, those terms in there. Exactly whether we'll specifically mention EGNOS, I don't know. But
and then obviously we're going to have to go through a certification process for the supplements that carry that support, either through the FAA on behalf of EASA or directly with EASA, right?
Correct.
Okay, thank you. I have a question. Early in the presentation, we were talking about the solutions the Service Center is offering. While we were looking at those, did we consider providing a backup WAAS receiver through the GPS 500W? In other words, in airplanes that have flight control systems that will accept vertical nav signals that have a GPS 500W installed, would it be feasible to support that installation and document WAAS capability?
are you thinking like the 2 Plus and the 3, Rob?
Yeah.
Okay, like the more recent ones for which we haven't worked out that Collins interface.
Where it might be
Garmin.
feasible for it to work and be certifiable.
Yeah, Dave, do you have a?
Well, right now, Collins equipment is not compatible.
I see.
Yeah.
And there's no plans at this point.
So it's the flight control system talking to the GPS 500.
Correct.
Got it.
Yeah.
Got it.
And really, I mean, because the FMS 3000 can already do that for those aircraft, it's not as high a priority as going back and where we did work out that interface and spent the money and worked with Collins and Garmin to make that all work on the 1-2. It's less of a driving need on the newer airplanes because they have a solution.
It's not that Collins is trying to exclude the Garmin and try to maximize their 3000 sales. It's really a question of Collins trying to justify spending money to develop the interface to Garmin.
Correct.
When they have a solution.
When a solution.
A lot of people would say 2 are better than 1. On the other hand, you've got dual GPS in the Collins. So.
You can, or you could have a Garmin as a second FMS, but you just wouldn't be able to use it for LPV.
I will say this, though, it is getting more difficult to certify dissimilar FMSs in the cockpit. We did consider that with CJ1 and 2. In fact, our solutions on the CJ1 and 2 will offer either Garmin WAAS or Universal, not both. The system will function with both, but we did not certify that because of the strong language that's in some of the guidance material from the FAA, specifically in Advisory Circular AC 2138C.
Yeah. And Europe has been singing that song for a while too.
Right.
Thanks.
Well, that brings to an end our presentation for today, and we thank you for joining us for this discussion. We hope that you found it informative. If you have additional questions or feedback for us, please send it in. As JD indicated, we want to hear from you. And if there are other topics that you would like to hear us discuss in a format such as this, please let us know what they are. We'd like to be able to provide that. Thank you, gentlemen, for joining me today. And, it was a pleasure to speak with you all.